How's it going, everybody? Today we're going to be looking at finding the area of irregular figures, or also known as composite figures. So I think it's probably best to obviously define what an irregular or a composite figure is. So that is a figure, right, or shape, a bunch of polygons made up of simple geometric shapes. Alright, so not to insult your intelligence, but think of when you were a toddler, or even back to like some of those kid shows like Sesame Street and stuff, where you may push a circle up against a square, or a shape that looks something like this. Like, let's say, for instance, you're talking about a pool. This is poorly drawn. So you have part of a rectangle, but the edge is half a circle here. So you have like a pool. Another thing you could think of is, if you're not that great at drawing the front of a house, you have this here, which is the front of the house, and then you have your roof looking straight on. So that's what we're going to be looking at today, and we're going to be figuring out what the area is of those. So it's somewhat of a review from previous years. It's just that we're kind of adding on to it now. Alright, so before we start, I am going to preface this with saying that this can be rather difficult. Remember, we're looking at just area, not perimeter. Alright, so most of our operations here are going to be dealing with multiplication. I may also post something that will involve all the formulas for finding area of different shapes, because you may feel a little overwhelmed. But as I said, this should be a review, but it's understandable that you may forget things. Alright, so you can see that we have, I'm going to shade, we have our parallelogram here. Alright, so that's shaded in. Alright, so that's what we're going to be looking for first. Okay, let me get rid of that. So, to find the area of a parallelogram, right, it's just going to be our base. Area is the base times the height. So, the base in this case is the 16 on top. It could be also the 16 on the bottom. It doesn't matter. So 16 times our height, which is 9. Alright, we get that, and it's 144. Alright, so for the area of that particular spot, it's 144, and we know that it's meters squared. Alright, everything's going to be squared here because we're talking about area. And then we have this half circle. Alright, half circle. So, we have area of a circle, which we know is pi, right, times our radius squared. Right, so this is where the tricky part is. So we have pi, which is 3.14 times radius squared. Well, the radius is not 16, it's 8. Remember, we're going to square that. So 3.14 times, well, 8 times 2 is not 16, it's 64. Alright, after we multiply, we'll see that that's 200.96. Now, remember, that is for a full circle. Do we want a full circle? No, that's half of a circle. So we're going to cut that in half. So we'll divide by 2, which gives us 100.48. Alright, so we take that, we add it to our 144.00. So the area for the half circle, which is right here, whoops, I'm going to draw a half circle, but, and then we add those together, 244.48. Our unit of measure is meters squared. Alright, let's take a look at this one. So, you may be asking yourself, when will I ever use this in real life? I promise you, and if your parents are right there, they can agree that this is a time when you would be using this with home improvement types of projects. You may think that you're going to hire somebody every time you need something to be done, but that is definitely not the case. I can attest to that. So if you're looking to cover the floor with tile or carpeting or hardwood or something like that, this is what you're going to do. Okay? So the first thing you want to do as you attack this is that you want to look for the two different shapes. Well, I can see in green here that I have a rectangle. Alright, so the area for a rectangle is simply length times width. I don't really care which one you designate as the length or the width. Alright, so let's say that 8 is the length, 5 is the width. So for the rectangle portion, we have 40 feet. and that's squared. So this is 40 feet squared. Alright, and then for the bottom portion we have a trapezoid. Alright, so this is where this gets a little tricky because trapezoids are a little bit hard to find the area. And like I said, I want to provide a formula sheet. So for the area of a trapezoid, we do half times the height times one of the bases plus the other base. Okay, so stay with me here. Well, the half is going to stay the same, and you'll be able to use a calculator for this. So the height for this trapezoid, remember we're talking about the shape here, is 4 feet. So we have times 4. Alright, now the bases, obviously this is one of the bases, 7. Alright, plus the other base, well, I don't see anything up here, up top. But guess what? It's the same thing as up here. They're equal. This 5. So the other one is 5. So we add these together. Order of operations 12. And then this you could all plug into the calculator at once. So we have 48. Cut that in half. So that'll be 24 feet squared. Alright? So we have this plus this will give us 64 feet squared.